Hey guys, welcome back to the YouTube channel. I hope you all will be doing well and you guys will be enjoying your life. So in today's video guys, we are going to discuss about the what is electronegativity, and we are going to discuss its trend in the periodic table. So electronegativity by definition is the relative tendency of an atom to attract a shared pair of an electron towards itself is known as electronegativity. So it is the tendency of an atom due to which it can attract the shared pair of electron towards itself. So this is called the electronegativity. Now there have the we have the electronegativity scales, and the following scales are used to determine the electronegativity of the elements. So number one is the Pauling scales, number two is the Mulliken scale, number three is the Alred and Roll or Robos scale. So these are the three types of the scales used to determine the electronegativity of the elements. Now we have few factors that affect the electronegativity. So the following factors affect the electronegativity of the elements. So number one is the atomic size of the atom. Then number two is the nuclear charge of the atom, that how much the nuclear charge of the atom has, and number three is the oxidation state of the atom. Number four is the shielding, or you can say screening effect of the inner electrons. So these are the factors that can easily affect the electronegativity. Now let's discuss it one by one. Atomic size. The larger the atomic size of an atom, the smaller will be the electronegativity of that element and vice versa. So if you increase the size of an atomic size of an atom, so the smaller electronegativity of that element will be produced. And if you reduce the size of an atom atomic size, the electronegativity will be similarly increased. Now number two, nuclear charge. So smaller the nuclear charge of an atom, the smaller will be electronegativity of the element and vice versa. So, so this is the way how nuclear charge affects the electronegativity of the atom. Now number three is the oxidation state. So the atom of the same element with higher oxidation state has more electronegativity than that of the lower oxidation state. For example, Fe3 plus has more electronegativity than Fe2 plus. These both atoms are of same element, but they have the different oxidation state, and the Fe3 plus has more oxidation state than the Fe2 plus. That's why it can easily affect the electronegativity of the atom. Now number fourth is the shielding effect. So greater the shielding effect, the smaller will be the electronegativity and vice versa. So if you increase the shielding effect, it will need the smaller electronegativity and vice versa. Now let's see the periodic trends of electronegativity. So the variation in a group. As we move from top to bottom in a group, there is an increase in atomic size, nuclear charge, and shielding effect. However, the combined effect of an increase in atomic size, nuclear charge, and shielding effect dominate over the force of attraction of the nucleus for the shared pair of electron, and as a result, electronegativity decreases. So if we move from top to bottom in a periodic table or in a group, there is an increase in atomic size. The atomic size increase if you move from top to bottom, and the nuclear charge and shielding effect also increases. So the combined effect of these increase in atomic size, nuclear charge, and shielding effect or the force of attraction, they affect the force of attraction of the nucleus and for the shared pair of electron. So the electronegativity overall decreases. So that's what it is explained in this paragraph. Now let's see the variation in the period. So as we move from left to right in a periodic table, so the effect of nuclear charge increases with no change in the number of shells. However, the atomic size decreases, and which results in the increase in the electronegativity. For example, fluorine is the most electronegative element with the electronegativity of 4.0, and calcium is which is also known as Cs is the least electronegative atom or element, and the electronegativity of the cesium is the 0.79. So that's why the variation in the you can say periodic table have the trends in the electronegativity. First of all, we discuss the variation in the group, and then we discuss the variation in the period. So guys, this was all about the electronegativity and the factors affecting electronegativity and the trends of electronegativity in the periodic table. I hope you liked the video, enjoyed the video. Till then, take care, see you in the next video.